Thank you for coming to the first Tacow in 4 years to the month since January 2020. Really briefly, history on Tacow. So Tacow started in 2006. It was the first international CocoaOS challenge. CocoaOS being the meetup for people programming in Cocoa and macOS, iOS ecosystem. Which I could see back then, now I could see it's mostly Swift.
Objects, web objects.
And web objects. We're not going to talk about that. And unfortunately, COVID shut everything down. Now we're going to try and bring it back. Once again, a huge thank you to the SCORE, to Anluan, and all of the SCORE for hosting us, for providing food. Honestly, we wouldn't be here if they hadn't put up the space. So, as much as we need speakers, we also need somewhere to go to eat, right? So, again, a huge thank you. We are trying to hit a bi-monthly cadence, so every other month. So we're looking at hosting the next meetup in March. If anybody would like to give a talk, please email me, hit me up on the meetup. If you haven't joined the Slack and you'd like to join the Slack, come see me in person tonight, or alternatively email me. My email's on the slide, but I can put it up again later. Please give a talk. You can give a lightning talk, or you can give a more full-fledged talk. If you've never spoken before, that doesn't matter. It's a very welcoming crowd of people, and this is your chance to work out any buzz in the talk before you take it on the conference circuit. And then finally, if you'd like to sponsor us with space, again, please see me. The SCORE has, again, very graciously said that they'd be happy to host this whenever, but we like to move around. People are from all different parts of the city, and not everybody wants to come to the East End. Some people want to go to the West End, some people want to go Midtown, whatever. The point is, if we can move around, it works out well for everybody. Anyways, I'm going to hand it over to Anluan to talk a little bit about the SCORE, and then we're going to get right into the topics.
We're going to have Tim here in a minute.
Right behind you.
All right.
I gotta say, you guys look amazing in 3D. Amazing.
Is it snowing inside?
Yeah. This is going to be a good year for us, I think. I'm super excited, and I'm going to tell you why. This is going to be all about my anxiety currently and how visionOS cured my immediate panic. By the way, did we mention we have a code of Cocoa for you guys to win? Just want to make sure we got that. So 2024 WWDC. I don't think many people know here, but I run a podcast called One Disco. We talk about iOS, and I had a couple of guests on prior to WWDC. We're like, we don't know what this is for. What's this AR thing? What's this headset that Apple's going to come out with? I'm well above the demographic that would think they'd be one of these things. But the SDK came out, shortly after the keynote, and just like everybody else, hey, look, I made an app on visionOS. This is actually my main app that I wrote in 2010 called Device Tracker, and it's written in Objective-C, and it runs on visionOS, which is kind of amazing, right? So the anxiety came from I was working at a company as a senior engineering manager, and I got laid off in August. But I had already booked a flight to go to California to look at Vision Pro at one of the developer labs, right? And I literally got laid off 3 days before I went to California. And I said to my wife, what do I do? We had booked flights, and we were going to stay in San Francisco, have a nice vacation. And she said, go. We canceled her half of the deal, and I went by myself. And it was great. It was great thing. So I went down fully expecting to be disappointed. And I talked to Daniel Steinberg just before WWDC, and he as well was a little skeptical about whether or not this is a product that the mass majority of us would use, right? I took a couple of weeks after I was there. I wrote this really nice blog post, put it up on Medium, and I talked about some of the points on our podcast. And the day after it was published, I got a call from Apple saying, "Can you please take that down?" So all I'm really allowed to say is I visited the Vision Pro lab in California. So if I trip up and I at least say anything about my actual experience at the show, I also listened to Mike Hurley's podcast where he talked about, he's allowed to talk about this, what he saw, right, because he's a journalist. So my disclaimer is anytime I say something that I shouldn't be saying, remember, Mike Hurley said it. All right, and it's on Cortex, episode 143, if you're curious about that. So I also, well, I'll get into that in a minute. But so what is this spatial computing thing that Apple introduced as a brand new platform for the rest of us, right? So part of my writing, I did some research, and I found out that stereoscopic photography, which is, those card, you see them at antique shows, it's like a wooden viewer you look through and you see a stereo image. That goes back to like 1838 was the first time that was mentioned, right? Kinescope followed shortly after. That's the thing where you put a nickel in, you watch a little movie, again, filmed in stereo, so again, virtual reality. So in the 20s was when the first flight simulators were introduced. The Viewmaster, which you probably played with as a kid, was from the 30s as well, which is amazing to think about. And computer-based VRs didn't actually start existing until 1960. And this is actually the VR headset that NASA uses, or was using during Skylab, or on the space shuttles anyway. And now we have, Meta's Oculus, Microsoft Halo, Google Cardboard, PlayStation VR, and Magic Leap, which I've never seen Magic Leap, but I'm told it still is pretty amazing. So here's the big question: why should you, all of you, why should you learn how to write apps for visionOS? Well, there will be businesses coming out in the next 2 years that nobody's ever imagined for, right? visionOS obviously is the language that you use to write for the Vision Pro. It's a flavor of iOS, very similar to iOS. You use the same tools. Written primarily in SwiftUI, but as I showed you earlier, you can run legacy apps that are for iPad with some caveats. You can run, and anything is basically compatible with an iPad OS. You can run it. And the Vision Pro and the visionOS are poised to create a spatial paradigm shift in the idea of computing. Spatial computing involves interacting with elements rendered in front and around the user of the computer. I wrote this in November. And just to circle back on the sort of where I see this going is, before the iPhone, none of this stuff existed. We didn't have Twitter, we didn't have Uber, we didn't have Lyft, we didn't have pumpkin spice lattes. Tinder didn't exist back then. And so I also write for Tacow along with Danielle and a few other people. But I got the opportunity to write the first visionOS. I mean, like after going to the lab, I was all in. Like I'm telling you, it's amazing. So everybody I've talked to who's tried understands what I'm talking about. So I wrote this course, visionOS, Introduction to visionOS, and it's pretty basic. And a lot of what we're going to talk about today is from that course, but also some stuff that I'm working on for the next, which is the next level of this. So, in case you don't know, there are going to be 3 types of apps. There's going to be window-based apps, which are like you open a big window, and it's going to float in front of you, and you can move it over here, you can open it here, over here. Those are going to be windows-based apps. I'm predicting that's going to be the majority of apps going forward, right? They run what's called shared space. When you're looking through, when you've got the visionOS device on, even if I'm looking at you, all I can see in front of me is what Apple calls a shared space. So I would open up windows and, have things like that. You can also create volumetric apps, which basically exist in front of the user in a 1 meter cube. I'm so glad to be talking to Canadians because you understand what I'm talking about. Americans have to translate it into 39 inches, right? And then the immersion apps are the ones you're kind of thinking of as what you think of when you think of a VR and AR thing. And that's where you can change everything that's in the visual periphery and auditory periphery of a user. You can use spatial audio to have sound effects, and you replace everything that the user's looking at, right? Depending on the kind of app it is, you can dial back. There's a digital crown up here. As Mike Curley said, there's a digital crown up here, and you can turn that and dial back the amount of immersion. So, and when you write your apps, you can decide to write a fully immersive app, like a game or something like that, where you want the user to be in the environment you're creating for them, or you can use a faster video where they see part of it. So, on the demo video that they put at WWDC, where the person is sitting in a movie theater, that will be like a pass-through where they think they're in a theater, but behind them is the rest of their house and their kids and their dog and what have you. So the tools that we're going to be using to do this are the same tools we're using every day, pretty much, with a couple of exceptions. Swift UI is going to be the majority of what you write. Again, you can write UIKit, but there's some limitations in terms of you don't get some of the nice effects that you get with visionOS, right? Reality Kit is the language that Apple introduced through AR experiences and all the QuickBooks VR stuff that they did over the last few years. That's going to be where you're writing the language that you're going to write. It's a version of SwiftUI tooling and other things. On the more computery, math, nerdy kind of side of development is the meta stuff, the AR kit. That's kind of goes down a different path. I'm not going to talk about that today. Xcode 15, obviously, and only on Silicon, which when the first version of the beta 15 came out, you could run it on Intel, but as of 15.1, you can't. And now 15.2 is officially shipped, so you get the visionOS sitting there with your Xcode 15. And Reality Composer Pro, I'm kind of calling it the interface builder of this environment, because it's where if you understand the math and you're happy to code everything, you can do it in Reality Kit, but Reality Composer Pro is kind of where Apple is pushing us, not pushing us, but suggesting we go. It's a tool that lets us build entities and apply what's called components to them and create things. So Reality Composer Pro is going to be a big tool. It's going to be used for that. So in the coding side of things, this is kind of the declaration, the app, the whatever my name is .app that you create when you first create a SwiftUI app. This is going to be the body, and you create a window group, and you have whatever your first view is, your content view or whatever. And then you set a window style, and you set a style as plain or automatic or volumetric. But if you don't put anything, it becomes automatic by default. And that's going to be the majority, as I said, of apps. To build an immersive app, you need then to import Reality Kit content, and that's the content part is what interprets what's been written in Reality Composer Pro. You create a style state, and you pass it in at the bottom here as what you're going to do. So in this case here, you could write this out long. It fits on the slide, but they could have done it. They could have put the current style in there and had immersion equals full, and then in dot full as well. And then you're going to add immersive space, and you're going to have this ID immersion scene is coming from Reality Composer Pro, and then you'll have some sort of view controller, what we call a view controller, view that is going to hold your immersive content. Another thing that Apple's added in the environment is a thing called ornaments, where you'll have a window, instead of having a tab bar across the bottom or toolbars, you're going to have like an ornament thing. I'm going to show you a screenshot in a minute, but you'll have it'll be like a mini picker. It'll kind of, as you look at it, it expands, and you can tap your fingers to select those kind of things. Those are going to happen automatically. If you write a tab bar or toolbar in SwiftUI, you'll get that for free kind of thing. But if you wanted to, you can write your own ornament. And here, for example, in one of my apps that I just recently did, I wanted to put a button at the bottom of the window. So I put the C at the bottom, put it down there so that it becomes an ornament for that. And using the glass background effect to get the sort of nice glass effect that we're going to get with visionOS. The meat and potatoes of writing VR content is going to live inside of Reality View. Reality View is it's an advanced SwiftUI view that Apple created for us to create these things. And so in this example here, in Reality Composer Pro, there's a immersive scene that's created, and you load that scene in here from the Reality Kit bundle. I might have missed a slide on that, but anyway, and then you add it to the content here, as you can see from the closure there. And then you have options to, if you wanted, you basically set this first closure is actually called a make closure, it doesn't have a name. You can call it make if you want, but you don't need to. It sets up all the objects in view, and then in the update you make all the changes. You animate, you create orbits, whatever it is you're going to do with your content. And then attachments is that you might have seen in some of the demos that have little windows that pop up with information on them, like maybe player stats, for example, that would be an attachment. And then when you're working in immersive space, Apple's concerned about, you just throwing a user right into immersive space, so they recommend that you give them an opportunity to open and close. So this is an environment variable that comes with the Reality Kit. Open immersive space and dismiss it, and then before you immerse your user into the app, they'll get this modal dialog to choose to make sure that the dog is not going to trip them or the furniture out of the way, kind of thing. As you're doing your Dance Dance Revolution app in VR. And again, so these are just examples of using those two closures. So Reality View and Model 3D are sort of two standard ways to load what's called an entity into your app. And talk about entities in a minute, but both of those modes are loaded synchronously, so you can use all the sort of sync await kind of sync await stuff that you use now. Model 3D is quick. Like if you're doing a product catalog and you just want to show a 3D shoe or something like that, or basketball, or whatever, you could use Model 3D. But I personally like the Reality View because it's more robust, there's more control over it. Again, that's where you can start doing the stuff that I showed on the previous slide, use the updates and test reviews. And essentially, you're using the built-in load entity model or method in both of those views to load your content. And then the content can either live in what's called a Reality Kit bundle, which is created like a sort of package that's created with your app, or you can load them directly from assets from like a screen or image or something like that you have in your project folder, your project navigator. So this is if you've done any kind of AR kit stuff, you may have seen USDZ. I still say USDC, sorry. Universal Screen Description. This is an extensible 3D package, if you will, that was created by Pixar to hold content. It can hold modeled objects, it can hold sound, it can hold colors, scenes, a number of things, sounds, spatial audio can be in there as well. If you've heard of USDA, the A stands for ASCII, it's basically a text file, and in that you can pack in different kinds of USC, USDC, A, PNGs, JPEGs, WAV files, any number of things, music as well. If you see a USDC crate or C, sorry, that stands for crate, and that's a binary encoded format. This basically makes the sort of models that you put into your apps portable in order to bring it in. And Z is pretty common. That's basically stands for zipped. You just change the extension and you can open it up and see what's inside it. It's not encrypted. It's not hidden at all. Again, developed by Pixar, and it's currently being maintained by Apple, Pixar, Audio Desk, and NVIDIA. And just one little sort of pro tip for writing, creating your own USDZs is, USDAs is, you can only have one root element in Apple's world, so that's kind of the top of the tree. And Python tools didn't get pasted in there properly, but there are tools for Python tools you can use to examine what's inside of a USDC if you want to take a peek inside. For the reality content, the main thing you're going to deal with is what we call entities. Right? And these are, it can be, like I said, a model, it can be a color, it can make up a material, or sound, and then you apply components to it. So for instance, if you have a ball that you created and you want the user to be able to hit that ball, use a component to make that hit recognized, add physics bodies to move it around on the screen, that kind of stuff, that have it interact with other objects. So components add physics and things like that, and then systems, Tacow there, so you say adds with a D. extra D missing there. These are add sort of functional programming changes to your entities. Like for instance, if you had a seaweed model and you wanted to make it look like it was underwater, you could write a program that would make it sway as if it was in the water. Another part that's kind of interesting about this whole development environment is physics-based rendering. This is where you take a material. If you've done any 3D work before, you have a model, you apply a color to it, you apply normals to it, which create texture, you create roughness to it, and these all together go into, or incorporated into the physics-based rendering. And what happens when you put an object in front of the user in visionOS is the environment brings in the natural lighting in the space, any kind of lighting you've added programmatically, or through images, and it makes it look as if that object is really in front of you. It's really amazing, a way to do that. So in reality, it's vertex shaders take care of applying all the light that the sensors around you are picking up and applying to your models. So it doesn't look plastic like most VR stuff does, right? Reality Composer Pro is another place where you're going to spend as much time in Xcode as you do, you'll spend time in here. This is kind of like the old, remember the old Xcode 3 days when you had two separate applications? It's kind of like that again. This is where you lay out everything. So for instance, here's a goldfish I downloaded from a site that has these things, and it's got a built-in animation in it. So I've loaded this USB-C in here, and over there, underneath the letter, you have your object right on the screen. But up here, you've got an inspector where you can set up different things. You can add components to it, add physics bodies, that kind of thing, to the actual entity itself. So on this screen, you can see that over here, you've got like a project navigator where you list out all the items you have. As I mentioned before, one, and you can see if you look at the top, there's two tabs. So this would be like there's two scenes inside this particular file, and you can load either one of them based on what you're doing in your app. At the bottom, you have all the assets, colors, materials, models, and things like that you brought into your program. And then over here, you have the inspectors that change based on what you're doing there. And the little plus that I got highlighted at the top there is there's a whole content library of 3D assets. So if you just want to get up and running and create stuff, you don't have to go. Apple's provided little robots and circles and spheres and like that, so you can play around with stuff before you need to actually get a 3D artist to create you a proper model, right? Another cool thing that's built into Reality Composer Pro is this thing called shader graph, and you can lay out. So you basically bring a model in. Here's like a cube that's been brought in. And then using different kinds of complex maths and splitting the image up into RGB and applying effects to it. In this particular case here, so all these purple things are things that influence, and the actual object and the output is what applies to this thing. So here's a set of effects that have been used to make this sphere color based on how close it is to the user, for example, right? So the closer this pink point at the bottom is closer to the user, the green spot at the back is further away. So you can do things like that where you can programmatically change your objects based on where they are relative to the user. Imagine like I think of a big Rubik's Cube kind of that kind of thing. I use that for this. Coming back to a little bit more code, here are 3 different examples of code that you might write without using Reality Composer Pro, right? So the top one is, one of the things you might have seen, I'll show you in the scene in a minute, is lighting an object with sunlight. Like if you've seen the home, has anybody seen the demo that Apple put out, the one with the home, the Earth with the satellite revolving around it? The Earth is lit by a sunlight file, right? And it's just basically a black file with a white circle in it. And that is applying, that's how we get the shadow to work like a single point of light like we have in the real world. So you set that up that way. I'm going to show you an image as well where I'm applying the second one here. Is I want to apply an underwater environment to the entire space, right? So in this case here, I'm using code to create a spherical mesh here of 1,000 meters wide. And I'm applying an image to a panoramic image to it from the inside. So we put the viewer's point of view inside the sphere, and then what they see is the horizon, right? So, and you'll see that Apple's doing this with video. They're making environments. You can sit in the side of the lake and use your computer as if you're in a college kind of thing, even though you're sitting in your boring little cubicle in the office. And then, the last example, here's an example where if I had an object like a marble or whatever, and I apply physics to it, it's going to drop. It's going to continue to drop to infinity because unless I create a floor. So here's an example of generating a plane that lines the floor and applying collision models or collision components to that and physics components so that it acts like the floor. The object's going to hit the floor, it's going to stop, right? And this is Mike Hurley actually said this, and it's great because I agree with him. I cannot express how beautiful the eye tracking is. It is amazing. You look at something like he says in the podcast that he didn't know his eyes were that good or that accurate. When you look at something, and one of the cool things about the device is it does this foveal thing. Like as you look at me now, if you're looking directly at me, I'm in focus. If you look over there, I'm not in focus anymore. Your brain doesn't let you know that, right? Well, the visionOS, or the Vision Pro device does the same thing. Wherever your eye is looking, it applies all of the math to make that in focus. It's an unbelievable achievement in terms of engineering. So yeah, you get goosebumps. I get goosebumps talking about it. You may have read Mark Gurman took a shot at the keyboard. I can't say I don't disagree with him. I found the typing was kind of awkward, so you're definitely going to have a mechanical keyboard or some other input device, because that doesn't be ready. But you know what? In a pinch, you have a keyboard. Right? This is actually my app that I wrote for my job search at the moment. And so I wrote it on iOS, and I used the Swift data and ran Swift data, and used the multi-format, I forget the term, the multi-format app. So I can run it on a Mac, I can run it on an iPad, I can run it on iOS, obviously. And I thought to myself, as Apple announced the ship date for when we can start placing orders, I think it's Friday, January 19th, why don't I just take my app and publish it on the App Store? So I did. A couple of things I learned in doing that was that the menu buttons at the top and where it says jobs up there. First of all, the jobs, it was actually called application. That big long name, and basically it included everything, right? So I found out how to basically make those buttons around, and down here at the bottom of that code I showed you where I manually wrote the ornament, that's that blue code, and then it makes a little toolbar at the bottom that has that up here. This is just sort of technical. Couple slides here. So the come to Jesus moment. I painted a painting in university where it was a cube, like an abstracted cubes and a horizon, and a space shuttle flying through it. And I was thinking like, what can I build when I'm at the lab, right? So before I went down, I went into Reality Composer Pro and I created these cubes, and then I ran it on the device. And I'm telling you, like, to see this thing that I wrote in my 20s, like this painting I made in my 20s, to come to life in front of me. Like, this is like 11 feet high and 7 feet wide and, 7 feet deep. This was the come to Jesus moment for me. Right? It was just amazing. And then, so this is another, so here is an example. As I was working out the content this is part of when I was writing the app for Tacow, the course on how to do this stuff. I made this particular video here. By the way, did I mention we have a giveaway? Let me just switch out of here. There you go. So this is actually the simulator. If you've not seen the simulator before, this is a quick little demo of a window app where you see this it has it here. This is the ornaments I was talking about before, the magic we get. And as you can imagine, as you look at these things, see how they kind of light up. That happens as you scroll your eyes across them. And you tap your fingers to make a selection, like this, right? And then this is the push me thing. This is an example of an attachment that gets attached to the actual object itself. So as it's swimming around, you can have that show up. And then Here's an example of opening an immersive space. You give the user a chance to say, yeah, okay, the dog's not going to trip me, all the cables have been put away, and then this is actually what they'll see. And you can see from, so a couple things about it, I didn't talk about the simulator, but you've got standard tools down here, like this bottom tool here is how you select things. This dolly tool here is how you zoom in and out, right? But this orbit tool, so this what you see in the background here is a panoramic image that makes it look like you're actually in this environment with this fish, right? And I made the panorama myself. Just found an image online and applied it to that sphere I was talking about before, and you get this giant fish following you, right? So when I was at the lab, I made a big giant hammerhead shark, and I had it circling my desk as I was working. It was really creepy. Then giveaway thing. So here are a couple of resources if you're curious. I would recommend you check out the Apple Developer app and all the content for all of the WWDC videos are there. Plus they keep publishing articles in there. They publish them all through the year. As well, there's also sample code for a lot of the apps that they showed at the keynote and in the State of the Union that you can check out there. This is a link to my course that I wrote for Introduction to visionOS. You can get a lot of the models and things like that from the QuickBook page that was put together. And Sketchfab is the site I couldn't remember where I got the fish from. There's a lot of people have put up a lot of free USDZ files that you just have to check, download, and create an account, and you can download stuff and play with it. So like that fish, for example, the animation of the fins, that's actually built into the USDZ file. So I just had to write the code to animate that. And this is who I am. Been an iOS dev for 14 years now. We're coming into our 10th year of the NT and More Than Just Code podcast. Been a co-author for American Spelling, interesting, for 11 years. All of my links are on my bio page, so if you want to head over there. But otherwise, I'm at Mitra on just about anything. And if you want to download the visionOS beta, it's a public beta. If you have your visionOS on you, you can download the beta and give it a shot. I mean, how it looks better for me because I can't quite find myself. And that's the end of my talk.
Questions?
I will take questions.
All right, so if anybody has a question, if no one has a question, I have one to start with. So.
Sure.
Oh, we got some gentlemen in the back. Two gentlemen.
So, I think I got a sense of what you were trying to convey here, but do you think this is a real game changer? And that's kind of a general question. And more specifically, one of the things that I was really curious about is using visionOS as just a replacement for monitors. Did you have a chance to do that at all?
I'm glad you asked that question the way you did because I can tell you that's 100% what I'm going to be doing with monitors, right? Like I have at home, I have a couple of 27-inch monitors, I have an iPad, I have a Mac that sits up on a stand, I have a keyboard in front of me. I'm going to be lying in bed for the rest of my life with my 4 monitors in front of me as my task in the air, you know. I mean, I told somebody else earlier that I fully expected to go down and be disappointed to have a janky experience and oh, it's another Newton or it's another watch. Because remember we always said about the watch here at Tacow and we got them and what the heck is this, right? This is the real deal. There's, I mean, like, I'm predicting like Uber and Twitter kind of stuff coming out of this, right? It's just going to be somebody's going to come up with an idea. It's going to a couple of years later they'll be sailing around the Mediterranean in their yacht. But yeah, this is I think even this first version. I mean, it's beautiful. It's like Mark Hurley said. Thank you, Mark. It's the Apple headphones that you can get. I forget what they call those things.
AirPods Max.
AirPods Max, yeah. It's that kind of build quality. Like it's just cool. And so that cube thing I showed you, I actually got up and walked around the room and looked at that. That was, for me, that was amazing. I thought I seated the audience with a couple of questions.
Oh yeah, okay, so given the current capabilities of the visionOS SDK, what would someone be able to, like a company that made Fruit and Joe, would they be able to like port their game to visionOS?
Yeah, I didn't talk about the whole Unity side too, right? There's an Unity SDK, you have to have a Unity Pro account in order to get that, so that's why I didn't bother putting an image on here, I'm kind of mad at Unity. Yeah, there is, if you have games, you can, I think it's totally possible to port them over, but it's like you gotta do something like Unity or rewrite some of the parts in it, right? Like I have an old Cocos 2D app that I wrote, probably not gonna really bring that in, but if I rewrote it again in something like a Stripe kit or something like that, I could probably do it. But again, it'll run anything, it'll run on my iPad, it'll run on this. But you don't get the nice glass effects, you get like a white screen as if it's like a browser or whatever, right? And I did mention you can actually use the code in your iPad app to take advantage of some of the things, like hover effect and things like that. Like the thing, when you look at it, it shines and stuff like that, you can add that to your games, to your existing apps.
So for Unity, you have the asset and you can just like apply a state machine to apply the animations for the object. Is that possible with the native library from Apple?
Yeah, so the part I didn't talk about was the AR-Kit metal side of things, which is sort of the more advanced rendering kind of engines. That's where the Unity side is going to come into play. Like there's kind of the reality kit kids over here, and there's going to be Unity kids over there. But they'll both be able to write code for the same device, right?
Okay. And another question is it possible for us to capture the real world objects and place and interact or put objects from our application in the real world?
Like you mean any object you create in your virtually, put it in there?
Like putting just like an object on top of this table, just mapping this table.
Yeah, I mean, so what you can't do in a simulator today, the rooms you see in a simulator, they're just imaginary. They don't have any physics applied to them, right? But what the LiDAR scanner does on the device is it scans the room. Like, I think last year they had a room planning app that came out with, you scan your room and figures out where all the surfaces are. And then with the AR-Kit, you can actually create anchors so that, you have a wall anchor or a floor anchor, ceiling anchor, and you can attach things to it that way. But that, so yeah, you can, the device will scan the environment you're in, and it will allow you to put objects on the table in front of you, like maybe a chessboard or something like that.
And is it possible in real time or only once, like when you start the app and then it's the LiDAR scan?
One thing that's cool about this that I heard was you can set up, you can be at your office and have your office in the Vision device, and then you can go home and have your home thing. And when you put objects in your house, or you put objects in the office, when you go home again, those objects are still where you left them.
Okay.
And when you come back to the office, they're still here where you left them. So you could do like treasure hunts, and I'm just thinking about these things off the top of my head. But yeah, you could do something like that.
Can you speak to the challenges the Canadians will have acquiring these?
Yeah, I forgot to ask, who's coming to Buffalo with me on 2nd of February? I know Gavin is. So what Gavin's talking about is a couple of days ago, they I think it was a leak by one of the reporters, right, on how it's going to work. Apparently you need to use the Apple Store app to order the device, and you make an appointment at a store to go pick it up, kind of thing. So right away they're going to know you're Canadian, right? So they may block you there. The other thing is if you need prescriptions like I do, it's $140 US for prescription lens inserts, and you need to have an American optometrist exam. So I think I was talking to you about it. We'll book an appointment before we go into the Apple Store. Notwithstanding how we're going to get it across the border, that's the other question.
So do you see the price point as a kind of blocker for this device to go mainstream? And if yes, what do you think the considerations should be for developing apps for?
So my answer to that is I did the math when it was first announced. I think in Canadian dollars it's going to be about $5,500, including the HST. I didn't calculate duties, so they're going to add that on, and prescriptive lenses. I did all the that's what it's going to cost for the 256 model. I'm already taking my money, right? Like once if you try it, you'll understand when I say that. Like it's not like, think about how much you spend on monitors, like the question earlier, right? Like how much you probably spent pretty close to that already on monitors. Think about how much, it's cheaper than Apple's most expensive display, right? And it's probably just as good, right? And it's got the same true tone and all that sort of fancy Apple hardware stuff I can't remember right now, but I would say, like, to me, it's at first I thought, yeah, it's a lot of money, but then again, you think about how much you spend on a Mac laptop, that kind of stuff. I 100% agree with the price point. Just take my money. Thanks, I guess that's it, right? Did you?
All right. Thank you very much, Tim. Who is a chief expert in visionOS? So when I was in 8th grade, my parents were too cheap to get me a word processor, so I had to write all of my school papers in Emacs and LaTeX. And I didn't know what VI or Vim was until I got to university. So when I finished university, one of my friends went off to San Francisco and he goes, "Oh my God, everybody here's doing this thing called XP programming. It's like, it's the latest wave. And one of the things that you do with it is you write your test before you write your code. It's called TDD." And that was 20 years ago. And it's similar to Emacs and VI. It has become a holy war unto itself. And we've got Uday who's going to talk to us about TDD or not to TDD.
All right, so good evening, everyone. My name is Uday. I work here at the school as an iOS engineer. I have some fellow iOS engineers here as well with me. So I see some familiar faces. That makes me a little less nervous. Also, this is my first talk, so if there are some hiccups, please excuse me for that. With that, a little bit of background about myself. I've been an iOS engineer since 2010. I've been with the score for 2.5 years. I was working before with a company called Try and Scale. You guys might have heard of it. It was a consulting company. Worked with some clients like Ford on their autonomous vehicles, iOS applications. Before that, I was living in Dubai, where I lived for 6 years before moving to Canada, like some of you here. There I worked with some of the big names like Emirates, EMA Properties, got to work on their client-facing apps. So yeah, that's my background. I like to code on iOS, and in my previous company, we used to use lots of testing and development. At the score, not that much. So but nothing against that. So yeah, we're going to go through I have an agenda for today. We're going to look at the origins, how testing and development came into origins, as my fellow engineer here already mentioned that. I'll talk about that a little bit. I'll talk about pyramid of testing, which some of you might be aware of already. Then we'll switch to TDD, what's the process, what's the mindset behind it, how do you go about it. We'll look at some of the best practices of unit testing. Some philosophy lessons might pop in here and there during that. Then we'll try to do some mock programming as well together to see how you start from scratch, and when there's nothing in an app, how do you go about writing the first test during the TDD first approach. After that, we'll have some limitations about TDD and benefits and some of the pitfalls to avoid, and finally questions. So with that, let's begin. So origin story. So it was developed long back, actually, as we mentioned that during the extreme programming days. The author of Extreme Programming came back, one of fellow software engineers. He came up with the concept in late 90s as part of extreme programming. So things like pair programming, which is becoming very prominent these days as well. TDD was part of those initiatives. So this is one of the codes. I'm not as big as Tim, but I'm going to write my codes here. So I'm just coding that back. So he says like, I'm not a great programmer, but I'm just a good programmer with great habits. So if you have great habits, you can still become a good programmer or great programmer. You don't have to be awesome, super awesome, flip a binary search tree. You don't have to do that. If you have good habits, if you test your code, you're good. So the idea of extreme programming was you take a concept and apply it to the max, to the extreme. So like the word extreme was used, hence. So everyone knows you write your test, you get better quality code, you have less bugs, but what if you take this process and take it to the extreme, right? So what if I write tests before I even start to code? So that's what led to this concept or this idea. And yeah. Next, I want to share something before we get into the nitty-gritties of TDD. It's called pyramid of testing. Some of you might have seen this, but on the left side here, it's more traditional way of software development where you have very less unit tests or test coverage, and then you have big amount of army of QAs who's manually running tests and trying to find bugs in your product. And on the right side, you have more like agile way of doing things, where you have like massive unit tests, which is at the base, and then you have very minimal manual testing, or then you have automated UI tests written at EM1, the tools that QA uses, automated UI automation as well. And then you have finally very less exploratory testing. So this is where you would want to see yourself. If you're here, maybe you can get here by. Hello. Can you hear me? Hello? I think I pressed the button. Okay. So if you're there, you want to get here. But yeah, I mean, you have to work hard to do that, right? Like you have to teach your programmers to test their code. It has to be part of your code reviews. You cannot just slide everything in and put it in tech dev, which sometimes you do. Yes, so moving on, what is TDD? Someone actually asked me here in the beginning when they entered, what is TDD? So some people call it test-driven development, some people call it test-plus programming. The idea is write tests before you code. Something to note, it's not a testing strategy. So it's a development strategy. So it's some sort of, some people say like this is how you're going to write a test using test-driven development, but that's how you actually develop your code. Right? Moving on, so how to start. So this is the main iteration that you do, and you repeat this over and over again. But before this, what I would say, first step for me is always I would write all the tests that I want to, write for that particular feature or requirement, and this gives me a holistic picture of what I'm trying to achieve and what are the acceptance criteria, stuff like that. And then I will start picking each of those tests one by one, and then I'll apply this cycle to that. So there are three main steps here: red, green, and refactor. And so the first step, as you'll see soon when I start writing some code, is that you write your first test, right? At that stage, you don't know what the class is going to be, what the interface would look like. So you start creating some objects that you have in mind, and you write some behaviors or tests for that, and you get lots of compilation errors. So here, it's okay to get compilation errors. There's nothing wrong with that. That's how you have to approach it. And then the mindset here is the key. it has to be very basic. You cannot like combine 3-4 tests under one and then have 3-4 assertions. It will be very difficult to backtrack. After that, so keep it simple, I would say. Once you've done that, you've written your very first test. The next thing is to make it compile, right? So you create those, and here the most important thing that most of the experienced programmers also fail to do is writing just enough code to make it fast. You're not planning to, at this stage, you don't want to develop the entire solution. You just have to write very minimal code. If it's as basic as returning false from a function, yeah, you should do that. So yeah, it's okay to have messy code. You might have some code duplications here. That's perfectly fine. There won't be any organization. Your design might be a bit imperfect. So you might not have your architecture in place at this point of time. So yeah, those things are going to be handled once you move to refactor, which is very important step. So once you've written your just enough code to make that test pass and compile, you'll run your test, make sure it's green, and then you can move to refactor. So this is where all the knowledge of the design patterns that you have, all the architecture patterns that you have heard of, be it like composable architecture or any other buzzword architecture patterns, Viper, bring it on. So you can introduce them here at this step. If you want protocols, you can introduce that. What will happen now is when you refactor, you have confidence that you have tests which are covering that functionality. So you can easily refactor without worrying that something else is going to break, and that's how your architecture is also going to evolve. And then again, you pick the next test, and then you're going to apply the same cycle again and again. So that's the main idea behind that. Some tips for writing the test. So we should write tests that matter. So we don't want to test like what UI table view does. Like once I saw a test which was like testing that UI table view is actually displaying that cell, which sounds very not. It's not adding any value to your test suite. So you would rather want to test behavior. Like if you're getting some data, then you should expect that data. So stuff like that, rather than writing trivial tests or writing something test for something which is already being tested. And this applies even for your own internal frameworks, right? So if you have internal private frameworks, you don't want to write tests for those frameworks again in your main app because they are already being tested. Test names should tell little stories. So you want to make sure that your test is not just developer readable friendly or cannot be just read by developers. It should act like as a documentation in itself. So when someone looks at your spec to your test, they should understand what is the behavior, what happens. So when X, Y, Z happened, what it should do, right? So yeah, I think this is also from the Extreme Programming book by Kentech, this little code. Then another thing is you should write isolated tests. So your one test should not depend on other. If you don't do this, then your test runtime on CI is going to increase that exponentially. So there should not be any internal dependencies amongst the tests. And even you can run tests in parallel if you have isolated tests, which will be faster and less CI consumption, and you save money. With that, let's move to some mock programming. I was talking to Daniela before this, and she was like, "This is a great idea." So here I need you guys' support for this. I've taken a very basic example. Okay. Cool. So, so this is the requirement that I have. for this very basic app, you guys might have worked at some point with login functionality, and all the tickets that you have, they are going to look like this. As a user, I want to log in, where my username and password meet with the criteria. Username must not have special characters. Password must be more than 8 characters, contain at least one special character and a number. So this was the product requirement. Now what I'm going to do, if you remember, the first step was to create like a list of tests from this. So this is what I have for that at the very bottom. I'll bring it to the top. There you go. So we have these 4 test cases. First one is username must not have special character. I translated it into simpler, smaller tests. So the second one, as you can see here, is password must be more than 8 characters, so on and so forth. So now if we go back to Xcode, I'm here using testing framework called Quick and Nimble. It's just like C-test. It just lets you write tests which are more like behavioral. So you can write behavior-driven tests, and it's like easy to read on the eyes, as you see. The main idea is you have like context, and then inside that you write what your test is, and then you have like a int closure as well after that, as you'll see soon. And then inside that you can add your assertions or arranging your. Can you see? Sure.
Command plus.
Okay. Is that fine? Good. Okay. So as we saw the first test, so I'm not even looking at the code yet. I just have this spec file here. I don't have any files in the project. This is the most difficult moment for anyone starting the testing or development, because you don't know what you're going to do, right? So I have this spec. So I envision that I'm going to have a login params validator at some point of time, and my first test is username must not have a special character. So as I said, test name should be like stories. So you can do like, when trying to validate username. I can write better stories when I'm alone, but since this is more programming, so I'll keep it a little brief. So when trying to validate username, the first thing is, so must not have a special character, right? So I'll try to break it down into one test first. So and I can nest like as many as I want. By the way, this is a very nice framework. I highly recommend this. If you want to use it, you can nest as many contexts as you want. So when trying to validate username, and then inside that, when username has a special character, then what do you want it to do? It should fail, right? So this is the first test. It should not have a special character. So now we can arrange our objects, right? So we can start here, very basic, what our interface is going to be, what our class is going to be. Let's call it login parents validator. Now here we need some experience, like if you ask this to someone who has never, programmed at a higher level or is not like very senior, then they might not be able to envision this solution. So you have to have some level of experience in terms of programming and with iOS as well. So here, let's say my subject is this. And then I'm going to do a basic setup before this, which is, I'll just initialize. And it's okay if we get compiler errors here. It's totally fine. That's acceptable. Don't get scared. well, I'm scared, but yeah. So we have our object set up. Now let's say so one thing while writing a test, I always used to follow given when then kind of approach, like you have given something, when you apply something to that, then something happens. But I was going through the documentation for this script framework, and they have come up with something called arrange, act, assert, which I find very nice. I don't know, given when then seems a little ancient to me. So arrange, act, and then assert. So first step is arrange, which we have already done before in the before each. I mean, we don't have to do that again. But here, we are going to have some sort of a function. So let's say the function is validate username. Actually, we can arrange. Let's say username is blah blah. It has a special character, so I'm going to use the dollar sign. Validate username. It takes in a string, so let's do this. And then in the assertion, what you want is, so this is going to return something, which is, then what we expect here is that this out is equals false, right? Because the username has special character and we don't want special character in the username. So I've written this test. If I have any syntax error here in the test, my fellow score engineers feel free to point it out. So now I run the test. So it failed, obviously, and I straight away know that I have to create this class. So I'm going to go ahead and create that class. And I'm going to open them side by side. Okay. So now I have this class. I have to create the class, obviously. And I have to add this function here, which is validate username. So again, I'm going to add very minimal code, which I feel is required to make it pass, which is the green state that we are trying to achieve. So we have this function. It should return false. Okay, I'll be lazy and return false here. It needs a return type. And I run this test. So build succeeded.
Ship it.
Test succeeded. Wonderful. So now the next step is when a username doesn't have a special character, then it should return true, right? Here we can do it return false instead, so it reads a little better than that. So what I'm going to do now is I'm going to duplicate this thing to save time. So actually we don't have to duplicate everything. So we already have this context, which is when trying to validate username. The good thing about this is when your test fails, it will print entire this string, like concatenated to each other. So that helps you understand which test is failing. So when a username does not have a special character, it should return true. So in this case, this doesn't have a special character, and then it should return true. So now when I run this test failed, right? So which test failed? Obviously it's this one. So yeah, I have to write code here now. So I'm going to keep return false as is. I have not yet moved to the refactor state because there's nothing to refactor. So here I'm going to write regex for that, which I already have for obvious reasons. and let's achieve the exact line that I need here, because this is not a syntax test. Okay, so this is what I'm going to return. So since I'm returning this, I don't even need return false because this itself is a condition. What's that?
The string. Replace self with string. String.
Oh, yes. Thanks. Okay, so that's what we have. Let's run the test now. Oh, I failed it. I think this has to be equal length because I was trying to find the interface. Yes, 16. Okay, awesome. So I think we have covered the username aspect, which was this test. Now let's pick the next test, which is password must be more than 8 characters. So for that, I'm going to close this for a while. And just like I created the context for this, I'm going to create a context for password as well. So when trying to validate the password, and what's the test? So it says password must be more than 8 characters. Okay, so you can break it down into like different contexts. So first one will be when password has less than 8 characters. What do you want it to do? Hit sure return. Right. So like this will build up. I'm gonna fast forward a little bit and do some cheating from here. And we are only going to do one test at a time. So I'm just going to take this. So here I create a password. I'm calling this function validate password with that subject, test object, and then my expected is equal false. So again, I go to my login params validator that I created. Now I'm at the right state. Now I create a function here, which is validate password, and it takes in a string again. That's how and then it returns false. So that's what I want my test to pass. So this is where I don't want my intelligence to come into picture. Like I know this test is like, yeah, it's testing the number of characters, right? But it should return false. But I only want my test to pass. That's my end goal here. So when I run it, my test passes, right? That's what I wanted. Now when I add another one here, context, which is when password has more than 8 characters, it should return true. So if I have, you can have equal as well, but for now I'll just do mine. So yeah, now it should return true. So when I run it now, it will fail, right? So yeah, so as I was saying, it gives you the entire description. Login params validator, and trying to validate the password, and password has more than 8 characters, should return true. What exactly happened here? So yeah, now I have to write code. The worst thing, you know. So let's cheat again. I'm going to get, actually it's just one condition. But I'm going to keep return false as is, and then if password count is less than 8, then I'm going to return false. So let's see if this passes. Oh, it failed. is that?
Line 19.
What's that?
19.
This one?
No, drop line 19. No, 19.
They're following through. Yes. Great. So we are doing more programming here as well. I didn't put that deliberately. I'm not acting down here. That was a genuine mistake. So yeah, our tests are passing again, right? So let's move on to one more. Let's do one more, and that's this, because I want to demonstrate the refactor state as well. So password must contain at least one special character, right? So I already have legends for this. Awesome. So if, and I'm going to duplicate the code here. So, oh no, I don't want to write code for this yet. I have to write test first. So, okay. So when password has, I'm just going to fast forward this and copy those stories from here. Integer is not what we want this one. So this is our test. When password does not contain a special character, should return false. So clearly this doesn't have any special character. We pass it to this, and let's see what happens. And here, yeah. So now I'm going to add logic here for validating that. But hey, we already have this, right? So I'm just going to do this. If it has a special character, then need to return false. So let's run this. And here again, it's the other way around. What's wrong here? So expected is false. We have this. Let me just go back to my actual project that works. So not equals near not. Let's try that. Run the test. And figure it out. Oh goodness. Okay. So we have this regex, which is exactly the same as this. So what's happening?
How do you know which one's failing?
Oh yeah, it's not this one actually which is failing.
Yeah, I think you changed the top. But yeah, that's
Yeah.
fine.
Okay, so I was right about this. Okay, so this one is passing, but yeah, this one is failing now. So when password has more than 8 characters, it should pass. So I think I messed up with this condition here.
It has no special character in the I guess.
Oh yes, that's right. So here we need a special character as well. Thank you. Awesome. Okay. So as you saw, like some of the previous tests also failed as you were trying to add more functionality. This is what you can avoid, as a surprise. Like if you're adding this feature after you've shipped the first one, you don't want your QA to find it out, right? So if you had that test backing up that code, immediately you can cache it, and you can even fix bugs using TDD. So yeah, now the next step. Now we see some code duplication here. Now we can stop here to write tests and code, but we see some code duplications here. Also, yeah, we have here return, which we can get rid of since it's a single line. So stuff like that you can change here. Also, this code is duplicated, so I think I can write an extension on a string, which I'm going to shamelessly copy from here. So this I can use here now. So if it does not have special characters, then it returns false. And the same thing I can use here as well. Yeah. Thank you. And now I can run this. And it has failed. So what is failing now? When the username has a special character, should return false. I think that's going to be a not here. Also, I can change this to username instead of str and password. Let me use some shortcuts if I can. I'm going to use this username, and then we can clean up some other code at this stage as well. So I think you're getting the idea. I'm doing refactor now, and as I refactor the code, some tests are breaking, some are failed, some are passing, and now everything is passing. So I think this is enough to demonstrate the mock programming, as well as also like what's the mindset that you need to have when you're starting from scratch. So I think you guys and girls have got the idea about how to approach this. Yeah, let's go back to our presentation now. So limitations. We have a couple of limitations as well. It's not all green. So obviously slow development, but this is a short-term side effect. In the long term, as you don't have a robust test cases and your code is well structured, you're gonna have you can obviously go fast as well. Maintenance is a problem, like fixing bugs in TDD is pretty hard. So yeah, that's another problem. But I mean, you can also fix bugs with TDD, like you just have to write a test which makes it fail, and then you can fix it. Learning curve is pretty high. There is not much material available. Also, there are not many people experienced with TDD. There are some companies which are doing strict TDD. I remember a company called Connected, which does like strict TDD. Next is rigidity as well. So as you saw, like rigidity, I was being very rigid on myself. I was forcing myself to write tests and not look at the code on the right side, which is very hard to do. You might just end up like, since I'm here, let me write the other condition as well, right? Because anyways, I'm going to write tests for that later. But yeah, you have to be rigid, which developers don't like. Benefits are you get well-tested code, as you saw, lesser production bugs, less surprises, cost reduction in the long term. So initially, our development cost might increase because it will take time for development. But in the end, you get good design and architecture. We didn't see stuff like adding protocols, and at first I was thinking about building a network layer, but that would have been a bit too much. Next is you get documentation. So as you saw the file, that test spec file, it looks like a documentation. Maintaining documentation on Confluence, you guys might have seen in your companies. If you have any, it's good. If you don't have any, that's also good, because on Confluence it's really hard to maintain those documentation. If some good kind developer was doing that, after he leaves, who's going to maintain that? This is getting maintained by itself. But that applies even if you're writing tests for your code. Even then you have good documentation. Pitfalls to avoid.
How does this improve architecture and design?
So as you saw, when I was demonstrating the example, that was a very basic example. But as you are going to write more code, like suppose you have a Swift UID, right? And you have some data fetcher for that, which is fetching the data. And you have written it within the view itself, within the Swift UID, and you don't have any view model or some other component which is fetching repository, for example, which is fetching that data. Then at some point when your test passes, you get the data, right? And you're going to realize that I can fix this. At that stage, you can use your knowledge of design patterns and architecture patterns, and you can create like protocols, you can add a view model and do the same operations, and then your test is again going to fail, which again you have to fix. But at least this time, you have a test which is failing when you do that change, right? So you start with something which is very basic. Like for example, you're writing a network function to fetch some models, right? You fetch user profile, you fetch some other data. But then you realize that these two functions are duplicates, right? So you can use generics for this. So then you introduce generics, then your test is going to fail. So that's how your architecture and design is going to improve. By design, I mean code design, not the UI design, by the way. So, but yeah, we can do that. Does that answer your question?
Sort of, yeah.
Yeah, it's hard. I mean, it is hard in itself. I'm not saying it's a holy grail or like one size fits all solution, but yeah, that's what we are playing with right now. Pitfalls to avoid writing trivial tests. As I said, we don't want to test list or UI collection view. Those are already tested by Apple frameworks. We don't want to test our internal private frameworks, and we don't want to write tests which are too large, so because then it's hard to backtrack which one was wrong. Third thing is teams fail to adhere, which is like you were doing TDD, somebody came, somebody left, and now you are not doing TDD, so it's maybe up to the team to decide how they're going to approach this. So yeah, you have to be rigid in terms of your development practices. Finally, the last question, with which this presentation started, to TDD or not to TDD. So it depends. This was the answer I remember for when I asked someone, like, should I use composable architecture or not? So like, it depends. But yeah, like on a serious note, like if you have a small app which you're gonna, it will be short-lived, it's not gonna scale up. Like we have Core Media app, which is in development for like 10 years now. Imagine if we didn't have any tests for that, what's going to happen? So it depends. If it's a basic indie app you're doing, then it doesn't matter. You don't have to spend that much time and efforts in doing TDD. So yeah, it's your choice at the end of the day, but you should write tests nevertheless. Again, there are some studies supporting TDD. This is from Springer. I wanted to show this because these are the actual researches that have been done by the companies which showcase or prove that TDD actually improved their software quality. Yeah, there's a link here at the bottom as well. Yeah, at the end, I would like to take some questions if you guys have any questions. This was my first talk, so I was a little nervous, but when my test started passing, that gave me real confidence. I was nervous that they would fail, but yeah, succeeded, which is good.
I actually have a question. So, do you think their program is almost a prerequisite for TDD? Because when you were talking about adherence, to really, get your team to actually do it, wouldn't that be like a good learning curve to kind of level people up, or is that not necessary?
So pair programming is more about like field code reviews, right? So pair programming is you're doing a code review before the actual code review. So both pair programming and TDD are part of extreme programming, but they are not interrelated to each other. So you can just start doing TDD even if you are not doing it right now. You can start doing it right away. Nothing is stopping you from doing that. Even if you don't have other developers who are doing that, you can start with that. But there's no correlation whatsoever.
Is it possible to avoid the pitfall of like rigidity and team failing to adhere by just having like a hybrid approach where some features in the team are others?
So you're saying like some features with TDD and some not?
Yeah, is that possible?
So do you remember my first slide? To do or do not, there's no track. So either you do TDD or you do not do TDD. It's like that. you cannot make like one feature with TDD and then expect like something to happen there and something not doing with TDD. Then you should try to do it for everything that you're doing, or at least have tests for that, for some backing at least. You can achieve that through TDD. But you can do a mix if you want. You can write tests for something, and some stuff like for unit tests, especially for unit tests, TDD is very good. But like for stuff like integration tests, for your snapshot testing, obviously you cannot do TDD there.
Why can't we just have a mix, like a hybrid? Because sometimes TDD might be too rigid for some things where the ticket feels really trivial or like a small thing. TDD seems like if you're walking on very like fragile grounds and things can go wrong easily, that's when TDD can be more powerful.
I mean, for me, like when personally from my experiences, like one condition can break the entire server. It has happened sometimes, in production, in pre-production also as well. Like some felt that this was a good fix to push, and they pushed it, and then that brought the entire server down. Have you seen that meme where those skittles are lined up and this guy comes up and plugs one, and the entire thing falls? So it's something like that. Like, you cannot consider a code trivial. It might look trivial to you because you're a developer, but it might be affecting something at a bigger level. It can fail like the entire app from loading. So yeah, it's your choice at the end of the day. But yeah, you should try to push for it.
I just have a question from a developer mindset perspective. So because everyone goes from the top level, let's say even if it's like they create a new controller and they just build it, then they write the unit test. So what are your suggestions how to tell them to think the other way around? So it's like this is not just a skill, it's like you have to change the whole mindset.
Yeah.
It's not just you, it's your team, it's your again the manager and the whole team.
Yeah.
So that's why I see like this cost extra. So the perspective, do you have anything on how to change someone's perspective on this?
So it's by practice, I would say, like teaching people about it. Like when I joined my previous company, they were doing some test-driven development. They were even doing like behavior-driven development, TDD as well. So it's more about coaching, mentoring, that kind of things. What they were doing is really they were using Gherkin and Cucumber, if I remember correctly, where the product used to actually write the specs, and then the developers used to look at that, and it looks just like plain English. So if you can involve your product in the TDD process, that would be really nice. Like the requirements that I showcased, those were written by myself, but product won't write that granular requirements sometime. But if you can involve them in listing state of tests, then you can align them, and they'll also see value in that being added. They'll understand, okay, these are the acceptance criteria, this is what needs to be fulfilled. Even QA will understand better. So yeah, you have to teach them, tell them how this adds value, show them those case studies if needed.
Great talk.
Oh, thank you.
Yeah, thank you. Great presentation. So I wanted to hear, like, from your previous team, if everyone would be required to write TDD, or if would be a mix in the team, that some of the team were not because I understand this is a paradigm that's really difficult to change, and we had that in the past when I was working. They were not pushing us. They were kind of it's up to you, but we want you to try. So how was that?
Yeah, there it was more of a pairing environment as well. Now my mom is going to kill me for saying that, but we used to pair a lot, almost 90% of the time. So in that environment, you have two developers working on something. It's not like they are checking on you or anything, but in that cases, you feel easier. I was getting stuck at some point, even though I practiced it 10 times. I was still getting stuck there. So I had you guys to jump in and make it easier for me. But yeah, I mean, it was there. It was like, yeah, everybody was doing it, but they were also pairing at the same time. So which makes it easy. It enhances it, but yeah,
Makes sense.
it's not necessary.
Thank
at the end of the day.
So when it comes to tests, TDD, a lot of the samples I see from code is for some kind of input, like user input validation. How, in a real app, for example, when there's a lot of network calls to the backend, so how you come about testing? For example, what's the correct field that the data comes from the backend is going to be, like how you come about that? Do you have to actually, like ask the front-end developer, and do you have to work with the backend developer to actually get the structure of the data? So that you're sure that you're accessing the proper field of the data, go through the structure of it to ensure that you get the, like for example, like in the network call setting, how you come about that in the TDD environment.
So what do we usually do when we write networking layer? We write networking layer, and then we hit a network call or URL request, and then we fetch the data and everything. And then we start thinking, oh, how am I going to test this, right? So what if like you do that before itself, you write a test for that. So you say, this is my network client. When it does the post request or fetch user profile, I'm going to get this format of data, right? And then you start writing your network client based off of that. That way is what you'll do is you'll be able to know that when I have to mock, when I have to use protocol, what is like a bare minimum code. So if you're writing a network client, you'll have what will be your dependency at the max URL session. So you'll know like, okay, URL session is hitting the network, I don't want that. So red, green, refactor, you're gonna go in those cycles. Instead of writing the entire client and then figuring out, oh, now I have to make these changes to make it testable. I don't even know how to make it testable. Let's talk to someone else. So
that would require some like collaboration between you and
ideal situation is you pair someone who has lots of experience, like with testing, not even TDD, but with unit testing, and you can get someone who has like slight experience with TDD or no experience of unit testing. That's like a good combination to have, because then the other person knows this doesn't look like we are going in testable direction, like this code doesn't look testable. So we have to fix it right away for that test to pass, or I need a mock JSON or whatsoever, or a file, whatever way you want to mock your objects, or a protocol, mock protocol. So yeah, that's how I think you should approach it.
That's cool. Thank you.
Right. As time goes on, you end up with more and more tests. You keep running all of them all the time. So, like, this is a perfect example of the logging stuff. If you've tested it and you know it's solid, you keep testing it.
I mean, yeah, like at the score, what we do is we have our CI, for every pull request. I mean, you don't have to test it on your machine, like every one of them. You can like create a graph pull request, let the CI do the work for you, and then see what's failing. If your test that you wrote was passing, something else failed because of the test that you wrote or the code that you wrote. So that's what we usually do. Like we create graph pull requests, and when something fails, we go ahead and either this is flaky or this is genuinely failing. That's like the usual approach that we take. But yeah, you can do something like that.
Any more questions?
I know that you use the framework to equipment and involved in business circumstances. What is TDD without these frameworks?
You can use exit test case in my opinion, but I feel like in exit test case, like when you write that function test underscore when something, So it becomes very big. And then also when something fails, then that assertion is not very descriptive, like what is failing. So with these with these frameworks, it like lays it out like what exactly fails. It encapsulates those contexts, and it's also readable. Okay, so with XC test case, I mean, yeah, a developer can read it, but some engineering manager who was an iOS developer once, they might not be able to get that.
Sorry, I do have one follow-up question. With now SwiftUI coming on, right, do you recommend TDD?
Yes. Actually, I was watching one YouTube dev. He's TDD Swift. Something his channel's name is. He does lots of TDD, so he actually did a SwiftUI with SwiftUI how you can do TDD. So I was very excited by that. I was preparing for this presentation, so I watched his talk as well. So he said like you have to SwiftUI makes it easier to write tests in general, even if you're doing TDD or not, because the view layer is already isolated from the data layer. That was not the case with UIK. So I mean, as long as you write good structured code, your data layer is separate from your view, then you can do TDD for that component, like for view model or other fetchers that you have. You don't have to write TDD for SwiftUI. Anything else? Thank you so much.
Thank you very much today. So that was an excellent first talk. So congratulations. I do want to point out, I don't know if anyone else noticed, but at the end, when Uday answered the question to TDD or not to TDD, he said it depends. But he forgot to say that you can't spell it depends without TDD. So maybe that was a secret message for everybody.